Hello everyone, this is Priyadarshini, Assistant Professor from the Department of Food Technology, Hindustan College of Engineering and Technology. So today we are going to learn about principle, mechanism and working of pulsed electric field method. So pulsed electric field, shortly PF, is a non-thermal method of food preservation that uses short pulses of electricity for microbial inactivation and causes minimal detrimental effect on food quality attributes. PEF technology aims to offer consumers high quality food. For food quality attributes, PEF technology is considered superior to traditional thermal processing methods because it avoids or greatly reduces detrimental changes in the sensory and physical properties of foods. Food preservation technologies are based on the prevention of microbial growth or on the microbial inactivation. In many cases, foods are preserved by inhibiting microbial activity through those factors that most effectively influence the growth and survival of microorganisms such as temperature, water activity, and addition of preservatives, pH, and modified atmosphere. In this case, the microorganisms will not be destroyed and will still be metabolically active and viable if transferred to favorable conditions. As estimates of the infection dose of some pathogenic microorganisms are very low, growth of these microorganisms in food is not necessary to cause infection. So, the general aim is to create value by maximizing the effectiveness of natural raw materials. Electroporation generates significant increases in yield, freshness, and flavor across a wide range of food and applications. In particular, PEF processing can be used to enhance mass transport process during extraction, pressing, or drying of fruits and vegetables. Permeabilization of meat tissue can be utilized to enhance drying, bringing, and marinating process. Applied on liquids and semi-liquids, PEF can achieve a non-thermal food preservation while maintaining organoleptic and nutritional product quality and freshness. Moving to the principle in pulsed electric field, the basic principle of the PF technology is the application of short pulses of high electric field with a duration of micro to milliseconds and intensity in the order of 10 to 80 kV per centimeter. The processing time is calculated by multiplying the number of pulses times with effective pulse duration. The process is based on pulsed electric current delivered to a product placed between a set of electrodes. The distance between electrodes is termed as the treatment gap of the PEF chamber. The applied high voltage results in an electric field that causes microbial inactivation. After the treatment, the food is packed aseptically and stored under refrigeration. Several non-thermal processing technologies were proposed on the basis of the same basic principle of keeping food below temperature normally used in thermal processing. This would retain the nutritional quality of food, including vitamins, minerals, and essential flavors, while consuming less energy than thermal processing. Then we are going to see about components of pulsed electric field processing. First, we are going to see the PEF processing system with basic component. The equipment consists of a high voltage pulse generator and a treatment chamber with a suitable fluid handling system and necessary monitoring and controlling device. So this flowchart represents the PF food processing system with basic component. So food product is placed in the treatment chamber either in a static or continuous design where two electrodes are connected together with a non-conductive material to avoid electric flow from one to other. Generated high voltage electric pulses are applied to the electrodes which then conduct the high intensity electric pulse to the product placed between the two electrodes. The food product experiences a force per unit charge, then so called electric field, which is responsible for the irreversible cell membrane breakdown in microorganisms. See, the main components required for a PEF application are an impulse generation system and a treatment chamber. A crucial prerequisite for economic and efficient production is continuous operability with high flow rate capacity, which has led to the development of continuous treatment chamber through which the food is pumped or conveyed while being exposed to the electric field at ambient, refrigeration, or elevated temperatures. Before treatment, heat exchangers may be used to preheat the media, and after the treatment, the dissipated electrical energy may result in a temperature increase which has to be reversed before the product is packed. Aseptic packaging is required to prevent recontamination. One of the main advantages of PEF treatment is its continuous operability with very short processing time. This means that a system can be easily incorporated into existing processing lines. So, a pulsed electric processing system consists of high voltage power source, energy storage capacitor bank, charging current limiting resistor, switch to discharge energy from the capacitor across the food treatment chamber. An oscilloscope is used to observe the pulse waveform. The impulse generation system transfer electric power from a low utility level voltage into pulsed high intensity electric fields. A simplified circuit for generating exponential decay pulses is shown. It consists of a charging and a discharging unit. So, in the charging unit, an electricity storage device is charged across a changing resistor by a DC high voltage power supply. So, the generation of PF requires slow charging and rapid discharging of the energy, as the pulse width is short in comparison with the time between pulses. Generation of exponential decay pulse requires a switch will turn on capability only as the total energy is stored in the capacitor bank will be discharged. Square wave pulses can be realized either by an incomplete discharge of a capacitor with a high capacitor by a switch with on off capability by a more complex pulse forming network that provides a relatively constant voltage across the pulse width. The power source, a high voltage DC generator, converts voltage from a utility line into high voltage AC that rectifies to a high voltage DC. Energy from the power source is stored in the capacitor and is discharged through the treatment chamber to generate an electric field in the food material. So, the maximum velocity across the capacitor is equal to the voltage across the generator. So, the bank of capacitors is changed by a direct current power source obtained from an amplified and a rectified regular alternative current main source. An electrical switch is used to discharge energy stored in the capacitor storage bank across the food held in the treatment chamber. Solid state switches, for example, silicon control rectifier, gate turn off, or insulated gate bipolar transistor. Switches require less complex driving circuits and easy to handle and control by external triggering and optimum variability of pulse parameters. Limitations have been found to the reliability in long-term use, in particular when exposed to reversal current in case of arcing, treatment chamber blocking, or electromagnetic interference. For high voltage pulses greater than 100 kV, a Mach generator is commonly used, invented by Mach. The treatment chamber in which the food is exposed to the electric field pulses contains at least two electrodes, one at high voltage and other at ground potential, separated by insulating material in different geometric configuration. Parallel plates, coaxial or collinear cylinders have been commonly used. A large number of studies have been performed using parallel plate systems, initially in batch phase and subsequently in continuous flow operation. Apart from those major components, some adjacent parts are also necessary. In case of continuous system, pump is used to convey the food through the treatment chamber. A chamber cooling system may be used to diminish the ohmic heating effect and control the food temperature during treatment. High voltage and high current probes are used to measure the voltage and current delivered to the chamber. PEF processing involves application of microsecond high voltage pulses in the order of 10 to 60 kilowatt. The high voltage pulses applied induces pores in cell membranes, causing a loss of barrier function, leakage of intracellular content, and loss of vitality. The treatment is applied continuously in a chamber, a set of multiple electrodes. While being pumped, that is liquid or semi-viscous liquids, or transported, which is solids, through the treatment chamber, the product is exposed to a high voltage pulses. The required treatment time is less than a second. The pulses are applied at repetition rates of up to 1000 per second to allow sufficient treatment of all volume elements. Besides electrical parameters such as field strength and a specific energy input, product temperature, and a product recipe also have an impact on treatment intensity. The schematic flow of pulsed electric field system is shown. If you see this, it shows a pulse generated from oscilloscope going to the treatment chamber, and the product is passed in the treatment chamber and the product is released after it is aseptically packaged. So this is all about pulsed electric field processing. Each creates a major component and impact in the food industry. So thank you for watching this video. Thank you.